Find the horizontal asymptotes of rational functions. So we were able to find the horizontal asymptotes of rational functions by finding the limit of f of x over g of x as x approaches infinity or as x approaches negative infinity. And we also discovered that looking for the limit will not always yield a horizontal asymptote. Sometimes we have no horizontal asymptote for a rational function. Theorem 1.6, limit at infinity and horizontal asymptotes. So when we are given a rational function where n is look at that, with n is the degree of the polynomial function in the numerator, and m is the degree of the polynomial function in the denominator, okay, the following rules apply. If n is equal to m, the horizontal asymptote is just this. Now, where did this come from? Well, that is y is equal to a sub n divided by b sub m. Those are the numerical coefficients of your leading terms. When n is less than m, the horizontal asymptote is y is equal to 0. The horizontal axis is the horizontal asymptote when n is less than m. When n is greater than m, our function has no horizontal asymptote. But in particular, when n is 1 greater than m, what your function will produce is an oblique asymptote. So an oblique asymptote is a slanted asymptote. It's not horizontal, okay? It's not vertical, so it's slanted. Find the horizontal asymptotes. But this time, we will not look for the limit. We will just use the rules to help us find the horizontal asymptotes. So here, n is equal to 2, m is also equal to 2. So the horizontal asymptote of this function is just y is equal to 1/2. Where did 1/2 come from? They came from the numerical coefficients of your leading terms. How about this one? Still, n is equal to 3, m is equal to 3. So they have the same degrees. Our horizontal asymptote is just y is equal to -2 over 5. That is -2, that is 5. So this one, n is equal to 1, but m is equal to 3. This will yield a horizontal asymptote whose equation is this, y is equal to 0. So that is the horizontal axis. The horizontal axis is the horizontal asymptote. This one, n is equal to 2, m is equal to 1, and so this one will not yield a horizontal asymptote. But later on, you will see that the asymptote for this rational function is an oblique asymptote. And I will show you later how to find the equation of the line for your oblique asymptote. I will show you the graph of these functions so that we can see how the graph behaves in relation to the horizontal asymptote. So this one is a rational function whose horizontal asymptote is the line y is equal to 1/2. And what we are seeing here is as x approaches infinity, our function approaches y is equal to 1/2. And the same when x approaches negative infinity. Our function also approaches the horizontal asymptote. Now look at this. Some of you are probably thinking that because it is an asymptote, your function must not intersect the horizontal asymptote. But that is not true. That is true for vertical asymptote, okay? But that is not necessarily true for horizontal asymptotes. This is the graph of this function, and as x approaches infinity, the graph of our function approaches the line y is equal to negative 2 over 5. And the same when x approaches negative infinity. So this one is a function, a rational function whose horizontal asymptote is the horizontal axis. So this one is the line y is equal to 0. This one has no horizontal asymptote, but it has a vertical asymptote. Look at that, look at that. So x here cannot be equal to negative 5. Because when x is equal to negative 5, this leads to division by 0. That means your function is undefined. So what that also means is you have a vertical asymptote. And the equation of that vertical asymptote is x is equal to negative 5. This is an oblique asymptote. The question now is, what is the equation of this line? How do you find the equation of this line? Well, this is what you do. You divide the numerator, x squared minus 2x plus 1, by the function in the denominator. Okay, so how do you write the result of this division as one equation? What this means is x squared minus 2x plus 1 divided by x plus 5 is equal to x minus 7 plus the remainder, and of course divided by x plus 5. That is how you write the result of your long division. Now the question is, what is the equation of your oblique asymptote? Well, guess what? This is the equation of your oblique asymptote. So it is an equation. You cannot just write it as x minus 7. So the way to write it is y is equal to x minus 7.